Okay, hi guys. I know I am back today, but I need to talk to a lot of you about your grades, and I think I'm gonna be expecting a lot of you to be homesick. I've heard of a lot of people getting sick lately, so I hope you're all doing okay and resting. All of you, you need to rest, drink your water, drink a lot of water, be healthy. That's all. Okay. So I'm just gonna put this here as usual. Listen to the video, please. It's hard to really learn and understand things if you're not also listening instead of just copying down what I'm doing. So if you're at home, you can, and if you don't have a printer, you can just do this on a separate piece of paper. If you do have a printer, you can print out this document from Google Classroom. Okay. So Lesson 522, writing rules from word problems. So on lesson 521, let's just double check that real quick. We kind of practice with solving equations and graphing an equation that we're given. Now we're going to just be given a word problem and we're going to have to graph it. Okay? Write an equation and then graph it. So here, you guys were never asked to write an equation for these, but we did see their graph, right? So we learned how to kind of analyze a graph whenever we have a system of equations. And now we're going to be given a word problem, and we have to create equations and a graph, okay? Oops, wrong one. All right, so here it reminds you that in lesson 5.2.1, you discovered that the point of intersection of two lines or curves can have an important meaning, okay? What a point of intersection means is that is a solution to all equations in the system. It basically means that that point does lie on both lines or both curves, whatever it might be. We're mainly just dealing with lines here, but anytime that two graphs intersect, that is their solution. They both share that exact same point. They could have more than one solution if we had a crazy parabola and then lines, right? That's two solutions, right? So that set there has two solutions, two intersections. We're mainly just going to be dealing with lines where they cross one time. Okay? So finding points of intersection is another strategy you can use to solve problems, especially those with two quantities being compared. So here is our problem. Buying bicycles. We have Latanya and George. So Latanya and George are saving up money because they both want to buy new bicycles. Latanya opened a savings account with $50. She just got a job and is determined to save an additional $30 a week. George started a savings account with $75. He is able to save $25 a week. So before I kind of analyze all this information here, let's see what our task is, and then we'll go back to the problem, or to the information they gave us. So it says, use at least two different ways to find the time in weeks when Latanya and George will have the same amount of money in their savings account. Okay? So we're going to walk through a few different ways. I think we're going to cover 3 different ways as I'm teaching this to you. If you are brave and confident and you want to try it on your own, I highly recommend you do try it on your own and then see if your way made sense. Okay? So again, I'm doing this in a video. I really like doing this one in class, but I feel like I'm going to have a lot of absent students tomorrow, so I'm going to make a video ahead of time just in case. Okay. So we need to figure out when they would have saved up the same amount of money. So let's look at Latanya. I'm going to make her orange. Okay. So Latanya opened a savings account with $50. So whenever you open up a savings account, you usually have to put some money into it right then. Excuse me, tired. She just got a job and is determined to save an additional $30 a week. Okay. Now George, let's make George green. George started a savings account with $75, so he had a little bit more to put away at first. He is able to save $25 a week. Okay, so what I would do is I would make a little table, first of all, okay? You can do this several different ways, but you could just rewrite that, or you can do like Latanya. I wonder if, oh, that's about as big as I got. Okay, hold on. Sorry. You guys can probably write way smaller than I can whenever it's full screen. Okay, so Latanya and George. Okay. George I had made orange, Latanya or green, and then Latanya orange. All right, so Latanya, how much did she start with in her savings account? What was her, what we'll call the starting point? She started the savings account with $50, right? So started with $50, okay? How much is she going to save each week? How much will she add to her savings account each week? It says she's determined to save an additional $30 a week. Okay, so she will add $30 per week. All right, now find the exact same information for George. How much did he start with? And how much is he going to save per week? I want you guys to go ahead and do that. So it says there, George started a savings account with $75. Started with $75. He is able to save $25 a week. So he will add $25 per week. Okay, so this is an informative table here. It's not an XY table, but it'll give us our information, right? So now we can kind of focus on the data here. One thing that is super helpful is to create a table such that like an XY table. Okay, so like with Latanya, let's see here. So let's make one. We'll use orange for Latanya. You can either go this way or another way, it doesn't really matter. So here we need to have weeks and money and savings account, right? So we might have to extend it, but we can start off week 0. You always want to start with week 0. That's the very beginning. See, I don't always draw mine very well. Let's see here. So you guys should always use pencil. I'm going to go up to week 4. I don't know. We might have to go further than that, but we'll find out. Okay, so this is Latanya. And then let's create one for George. I'm going to leave some space just in case we do have to extend a little bit further because I don't know when they're going to have the same, right? So basically what we're going to do is we're going to fill in this table until at the exact same week they have the exact same amount of money saved up. Okay, so we might be adding on quite a bit. So this is one way to do it. All right. So this is George. All right. So Latanya at week 0, how much did she start with? How much did she put in her savings account? So at week 0, she has $50 in her savings account. What about at week 1, after 1 week? How much did she say that she's going to add per week? So $30, right? So she's going to save an additional $30. So 50 plus 30 will be 80. And she's going to keep adding $30 into her savings every single week. That's pretty good. That means she's saving $120 a month. So that's good to put away money into savings accounts. Once you guys get a job, if you don't already have one, save your money. Don't just spend it. Trust me. Save it. All right, so we can go all the way to week 4. So I'll pause there. I mean, I could keep on going, but let's just see what George's looks like, okay? And see if we have any intersections yet. All right, so George started with $75 at week 0. How much is he going to add per week? So after 1 week, how much will he have in his savings account? So if he adds $25 per week, we add 25, this becomes 100. Add 25 again. All right. So now if you guys look here, we're not quite there yet, right? So there's no week where they have the same amount of money. So what we want to do is we want to add on another week to each of them. And kind of just keep on adding on more weeks until you get to the amount that they have the exact same. And it has to be within the same week as well, right? There we go. Week 5, they both have $200 in their savings. That is their solution. Now, there's multiple ways to find the solution, but a table is definitely one way. Okay, so this was an XY table, if you guys didn't notice. So the weeks are the X values, and the money, or how much money is in the savings, is the Y. So on our graph down here, you guys could label that. So this is the Y-axis, this is the X, this is the time in weeks, and this is the money in savings account. Okay? And you guys want to number them. So you want to kind of think about, okay, we got to get all the way up to $200 on this graph, at least, because we have to show their point of intersection. So I want to just see how many dashes are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could go by 20s, and then that would get us up there. And you'll just have to like know that in between here, those would be 10s. If we go by 20s on the main one. So it'll look like this. So this would be 10. In between that would be 5, then 15, 20, 30, 40, 50, 60. And I'm just going to write my 20s here. So you guys have to see, like, with whatever graph you're given, what's a good way to scale it. This one would be a good way to scale it. And you can write down the ones in between if you want. You don't have to, but it helps you whenever you graph. And then if you needed to put more dashes to show the 5s, so these little ones I'm putting in, those are all 5s along this graph, because they're in between my 10s. Okay? And now the time in weeks, you can spread it out a little bit, because if I did 1, 2, 3, 4, 5, they'd all be pretty close, which is fine. Either way, it works fine. But if you wanted to spread it out, you could do 1, 2, 3, 4, 5. Like, that's fine too. As long as you're skipping the same amount each time, like here I'm skipping 2 units every time, that's totally fine if you guys wanted to kind of spread out your graph. So now to graph these, right? Let's graph Latanya first. I'm going to use orange. I should have said earlier, grab a colored pencil or something to keep these separate. That would be a really good idea. I'll try to remember to put it in Google Classroom. So Latanya started with $50. So at week 0, so this right here would be week 0. At week 0, she has $50 in her bank account. Now she's going to add $30 each week. So at week 1, she's going to have $80. So I'm going to plot a point right there at 80. 1, 80. That's that point. And then at week 2, we know she has, and you can also just use your graph, right? Or your table up here, sorry. Your table. We know she has $110 by week 2. It definitely adds up if you guys were to save, you know. It's so good for college or just living afterward, after high school. Save your money. All right, and then week 3, $140. Week 4, $170. Week 5, $200. Right? So you guys see this, and you guys could connect the points to kind of see it a little bit better if you want. You can see how her money is growing, or how her savings account is growing as she's adding more money to it. So this is LaTanya. Okay. So let's go ahead and graph George. Right, so George starts with $75. I encourage you to please pause the video, try it on your own first, okay? So for George, his y-intercept is going to be at 75. So it's right in between that 70 and the 80. Of course, his is difficult. So then after 1, he'll be up at 100. After 1 week, $100. And then after 2 weeks, he's going to have 125. So I'm kind of looking right here. And then I know that right there, that's 125 approximately, right? It's going to be a little rough sketch, but it works. Okay. And then week 3, he has $150. So week 3, 150 is going to be right here. So you see they're getting a lot closer each week in the amount because he's only putting in $25 and she's putting in $30. So you can see George's is going to be a little bit lower. Like it's not going to have as much of a steep slope as LaTanya. So he has a slower rate of change. And then at 4 weeks, George had 175. So yeah, see, it's going to be like right above it. If you see that. It's going to be right there. And then week 5, George also had 200. So we can go and draw our line. Oh, my dots aren't perfect, but they're pretty close. So that is George. The green line. Okay, so this shows their solution. Now, this solution is a point. This point is 5, 200. 5, the x-axis represents weeks. So this is 5 weeks, $200. So we can write this as a sentence. My solution is at week 5, LaTanya and George will both have $200 in their savings account. Right? So this is really, really important that you guys are able to articulate and put into words what the solution was, like what exactly you found, right? That's really, really important. Okay. Now, let me see real quick. Oh, no, it doesn't. Let me see. Okay. So another way to do this is to write equations. Okay. So I'm going to teach you guys something new here, something very, very important. So what we'll do here, we'll write them right underneath some of this stuff here. So looking at the tables that we have here, I want to write a rule for LaTanya and a rule for George. Okay, the rule is an equation. So y equals mx plus b. Okay. And this obviously is not their rule, but I'm just going to write that y equals mx plus b to remind you what we do with that. Okay? We need to find their growth and their starting point. in order to write a rule. So right now you have the information. It's all right here. I need you guys to write an equation for each LaTanya and George. So for M, what is LaTanya's growth each week? She is growing by $30, right? So it's going to be 30x. And how much money did she start with in her savings? She started with $50, so plus 50. So that is LaTanya's rule. Okay? Now George, if you didn't get LaTanya's, try George's on your own. George grows by $25 each week. So that is his M, or his growth, or slope. All of those are the same thing. M, growth, slope, rise over run. B, his starting point, he started with $75. Okay, so I'm going to teach you guys another way that you can solve equations really fast. Okay, so I taught you guys that you can use tables, but sometimes if the numbers get really, really big, a table just is not as efficient as an equation. And then if you can't make a table, then you can always make a graph without an equation. So learning how to use these equations over here, the rules, is extremely important and beneficial. I know a lot of you guys like shortcuts. Equations would be called a shortcut. All right, so I'm going to rewrite those down here. So for LaTanya, we had y equals 30x plus 50. And for George, we had y equals 25x plus 75. So if we want to find when they are the exact same, that's our goal, is when they have the same y, which y is money, right? And x is weeks. So we need to find the same weeks and the same money for each of them. So what you can do is solve the system of equations. So I'm going to say solve the system of equations using equal value method. We need to know when they're going to have equal values. So what you can do is, since they are each already set up equal to y, right? We need to know when does y, or actually here, let me use my colors here. We need to know when does y equal y. When do they have the same amount of money? Right? That's dealing with money. I need to know when does that happen. So if LaTanya's y equals 30x plus 50 and George's y equals 25x plus 75, we can write our equation just like this, and this is equal values method. We need to know when do they have equal values for y's, right? For each of their y's. When is the y the exact same? To find that, we can find out what x is whenever we solve for x here, okay? So that's our first step. Solve for x. So what I'll do is I'm going to subtract 25x from both sides to move my x's over to the left. So I end up with 5x plus 50 equals 75. So it's just solving for x, just like normal. This is why I taught you guys it so much, because now we're using it to find other things. So now we can subtract 50 from both sides. So we're left with 5x equals 25. And then now divide both sides by 5. You should get x equals 5. Okay. So x that means 5 weeks. So at 5 weeks, they will have the same amount of money. Okay, so now our next step is to use x equals 5 to solve for y, which is the money, right? So if we have those two equations, we know y equals 30x plus 50, and we know y equals 25x plus 75. Well, if we now know x, right, if we know x is 5 weeks, we can plug in 5 for each of these weeks. And then that tells me how much money, y, they're going to have at 5 weeks. Okay? So this will end up being y equals 30 times 5 plus 50. So I'll solve this one first, and then I'll do George's. So this is LaTanya. How much money she'll have at 5 weeks. Okay? So this would be y equals 150 plus 50, which equals 200. $200 at 5 weeks is what that's telling us right there. Okay, which we knew that, right? If you guys look back at our solution, it was 5 weeks, $200, right? So this is just another method you guys can use. So now for George here, if we plug in 5 for the weeks, 25 times the weeks plus 75. So 25 times 5 is 125. Plus 75 is 200. So same exact thing for George, $200 at 5 weeks. So technically, whenever you have a system, you really only need to solve for one of them, because the whole goal was, when are they the same? And if the x tells you when the y's are going to be the same, you really just need to plug in one of the x's to one of the equations, and then you'll know that the other one should also equal that same amount. I always recommend, especially as you guys are just starting out, plug it into both of them and make sure that you get the same number, right? Because if you don't get the same number, then you might have solved the wrong x, and then you'll want to go back and check your mistakes there. So again, this is the equal values method, okay? So if you need to pause to make sure to get this all down, please do so. This is really, really important. Okay. So now we have Gerardo. So Gerardo decided to use tables to find the point of intersection of the lines y equals 4x minus 6 and y equals negative 2x plus 3. His tables are shown below. So our goal here is to find when those two lines are exactly, or cross and have the exact same point. So I want you to look at the tables here. Do you see any of the same points? So they all have x values negative 3 to positive 3. But then if you look down at the y's, do they have any that are the same? Gosh, I hope I'm not just tired, but I don't see a single one. So in this case, the table did not help him find the point of intersection. Okay? So we need to try to figure out where exactly his point of intersection is. Okay? So there's multiple different ways to do this. I don't see a common point in the table. So you can say, like, I do not see a common point in the table. Need to use other method. Methods to solve. Okay? And that's totally fine. Sometimes you won't be able to solve something that's given to you. So you have to use a different method. So I'm going to write down these rules right here. Y equals 4x minus 6 and y equals negative 2x plus 3. Okay? So I just copied those down from up here, just so I have them down below. So now it says, now graph the rules on the same set of axes. So we have X and Y axis there. We have one graph. So the way that we graph, I think some of you guys were struggling with graphing, but we did it last semester. So this here, that number is our slope, okay? So that is our rise over run. So in this case, since it's a 4, we can put it over 1 to replicate rise over run, right? Except 4 divided by 1 still equals 4. Same thing here. Rise over run is going to be negative 2 over 1. So that one will be going down. Okay. Now, this number here, that is your y-intercept. So that's a good first point to start at. You need that point. So that is your y-intercept for each of these. Or you can call it your b, right? So remember, this is all y equals m is the slope, mx plus b. Okay? Very important. All right, so let's go ahead and graph. So let's graph the one on the left first. Okay? So y equals 4x minus 6. So my y-intercept is down here at negative 6. Okay? And then I need to draw a slope triangle where I'm going up 4 because it's positive and to the right 1 because it's also positive. So I'm going to go up 4 to the right 1, and that's a point. Up 4 to the right 1, point. Up 4 to the right 1, point. Up 4 to the right 1, point. Okay? And you guys could have also gone backwards here. There's enough room. You don't have to, but you could. So I'm going to give this one a color. Let's call it, well, we'll do it in blue. Okay? So it's really good to graph with different colors just so that your eyes are able to see the difference between the two. Right? So now I'm going to go ahead and erase all of those slope triangles. So if you need it, pause the video right now. I'm just going to try to declutter my screen a little bit. All right. So that is the line y equals 4x minus 6. So now I'm going to plot the other one. So y equals negative 2x plus 3. Positive 3 is my y-intercept. Okay. And now my slope is down 2 over 1. So we go down if it's negative or to the left if it's negative. But here it's down 2 to the right 1. So from that point, I'm going to go down 2 to the right 1, point. Down 2 to the right 1, point. Down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. And you can keep on going forever, right? But I see that they're going to intersect. So let's go and make this one. I'll make this one. I'll make this one red. Okay? So here you can draw your line through the points. You can use a ruler to help make it a little bit straighter. Okay? And then for me too, I'm going to extend it all the way up. And if you guys extend it all the way to the edges of the graph, you don't technically need to draw arrows. Like, I didn't need to draw one right there. If they're all the way to the end, that's telling me, oh, okay, they're going to keep going on forever, right? So that would tell me that that would be my arrow, technically, okay? So looking at this point of intersection, that is their solution, even if we might not know exactly what that is, right? But what does it look like to you? What point does that look like to you? Try to write it yourself. That looks like it's at 1.5 because it's right in between the 1 and the 2 and then 0. So I went to the right 1.5 and up or down 0. Is this the last one? Yeah, okay, cool. Feels like a really long video. Okay, so what we're going to do is use the rules to confirm your answer to part B. So we're going to see if our solution is for sure 1.5 comma 0. So even with graphing it by hand, Desmos might be able to tell you guys right away. But like on a test, graphing it by hand might take a little while, right? Or it might not be as accurate as you want it to be. So we can use equal values method. Okay, so if we know y equals 4x minus 6 and y equals negative 2x plus 3. Okay, actually, sorry. I'm going to rewrite them in the colors that I had. It kind of helps a little bit. So the whole goal of solving a system is to find out where do they have the exact same point? Where do they share a point at? So it's where do they have equal y's and equal x's. So my goal here is to find where my y in one equation equals the y in the other equation. That's the goal. So since we know that the blue y equals 4x plus 6, I can write that here to replace it, like substitution. And if I know that the red y equals negative 2x plus 3, right, and those are equal to each other, I can now solve for x, right? So my first step is to solve for x once I have the equations equal to each other. So I'm going to draw my line and try to solve for x on your own. See if you can do it. So pause the video. All right. So it doesn't really matter which one you do first. It does not matter. I'm going to go ahead and add 2x first just because I don't like that negative. But I think I'll end up with the negative somewhere else anyways, so we'll see. So this will give me 6x plus 6 equals 3. Just brought these down. So now I'm going to subtract 6 from both sides here, because I can't combine that with 6x. So now I'm just left with the 6x here. 3 minus 6 is negative 3. Did I graph this wrong? Oh, darn it. I'm sorry, guys. I was going to say I should not get negative 1/2. Whoops. Look at that. I wrote this as plus 6, not minus 6. I wonder how many of you I'm driving absolutely insane right now, whoever caught that mistake. So hold on, let's redo this then. We just want to, you might not need to erase it all, but just because that needs to be a negative 6, I'm so sorry. Okay, negative 6 there. Glad I caught it now. All right, so same thing, still would add 2x to both sides. 6x minus 6, not plus 6, equals 3. Okay. So now I add. That still wouldn't be right, because that would be 9. Where else am I making a mistake at, guys? Let's see here. Well, let me, 1.5. Oh my goodness, yes, I'm too tired. Never mind, I'm like thinking ahead at what our answer is going to be and worrying that it's going to be wrong. But we got it. Trust the process, Champlin. All right, so 6x equals 9. And then if you divide both sides by 6, I kept thinking I was supposed to be getting 0.5, but it's 1.5. 9 divided by 6 is 1.5. Sorry about that confusion. Okay, so this tells me x equals 1.5. So now my second step is to use x to solve for y. So again, you could use both of these equations, right? But if you only solve for one, that should be the exact same as the other one, like what you should get for the other equation. So I mean, it's good to just do it for both just to double check, but you know. So if x is 1.5, I'm going to put 1.5 in here for both of my x's. And what should I get for my y's if I did this all correct? What should I get according to our graph? Our graph said our solution is 1.5 comma 0, and this is x comma y. So I should get 0 for each of these. So that'll be a good check to see if we were able to accurately state the point on the graph. So 4 times 1.5 is 6. 6 minus 6 is indeed 0. Perfect. Okay, so that one was good. So now let's check the red one. So negative 2 times 1.5 is negative 3. course, you can use a calculator for that. I just know it in my head. Y equals 0. Negative 3 plus 3 is 0. So it checks out. Our solution is 1.5, 0. So this is also known as, aka, our point of intersection. It's where the lines will cross on the graph. Okay? So if I were to draw. Point of intersection. That's what it is. It's where they cross. Alright, so you guys will see problems like this on Khan Academy. You might be given a problem like, if they say, they might ask you is 1.5, 0 a solution to y equals 4x minus 6 and y equals negative 2x plus 3? So we already know it is, right? This is just my example, but the way you guys could do this is you would take the x value and plug that in for each of your x's, and then you would take the y value and plug that in for each of your y's. So this would be good to write down if you guys want an example for your Khan Academy assignment, because it is a little bit harder if you don't have an example. So what you would do is you would plug those in and then simplify and see if it's a true statement. So here in this case we will get a true statement. So let's see what that is. So y is 0, x is 1.5. Okay, so I'm just plugging in the values that they gave us. You guys know every point is x, y. That's why. So then same thing here, 0 equals negative 2 times 1.5 plus 3. And so 1.5 was my x, and 0 is the y. So now we simplify. So this side just stays 0. 4 times 1.5 is 6. 6 minus 6 is 0. So that is a true statement. 0 equals 0. It has to be a true statement where each number is the same, right? It has to be saying something true. Like if you got 1 equals 0, no, that is not true, right? So that would have not been a solution to that equation. But in this case, it is for that equation. Now on Khan Academy, don't just do one of them. You have to do both, okay, just to make sure. So 0 equals negative 2 times 1.5 is negative 3. Negative 3 plus 3 is 0. So cool. So yes, the point 1.5, 0 is a solution to both equations. Okay, so again, this should help you out with the Khan Academy. If you need any extra help, watch their videos, take notes on their hints, and then also email me if you need the help, or come in and see me at lunch next week. Okay, I'm happy to be back. Hope you're all doing well.